Here's another example of evaluating the derivative of an inverse function without actually finding out what that inverse function looks like. Once again, we should make sure that the function f, in this case x plus 6 divided by x minus 2, does have an inverse. And again, I think the easiest way to do that is to graph that. Make sure that the graph looks like it is 1 to 1, that is, it passes the horizontal line test. When graphing this, I will once again remind you, make sure you put the numerator in parentheses and the denominator in parentheses so that the calculator interprets order of operations correctly and gives you the right graph. Now, as we take a look at this, we want to find the value of the derivative of the inverse function at some point a comma something. So we know that the point 3 comma something is on the graph of f inverse. That means that the point something comma 3 must be on the graph of the original function f. Again, that 3 becomes a y value, so we set 3 equal to x plus 6 divided by x minus 2, and we solve. So 3 times x minus 2 is going to be equal to x plus 6. That is 3x minus 6 is equal to x plus 6. That says 2x is equal to 12, or x is equal to 6. So our point on the original function is the point 6 and 3. The point on our inverse function is the point 3 and 6. Now we can go to the derivative of the original function. So f prime of x is going to be equal to the derivative of the top, which is 1, times the bottom, which is x minus 2, minus the derivative of the bottom, which is 1, times the top, which is x plus 6, all divided by the bottom, x minus 2 squared. So that's going to end up being negative 8 divided by x minus 2 squared. We're interested in what happens when x is 6. So f prime of 6 is going to be equal to negative 8 over 16, 6 minus 2 being 4, 4 squared being 16, or negative 1/2. That means at the point 3 comma 6, f inverse prime of 3 will be equal to negative 2, the reciprocal.